I had an email question from a student in regards to these problems that are from the 6.2 homework. So this is from section 6.2. Sorry, I didn't write that. Numbers 5, 6, and 7 in the online homework. And they're good problems. I think that they're already covered in the video but that I made as a help for this, but I thought I would answer the question directly and provide the video solution for all. And so this is the setup that's here for these three questions. We have IQ scores that are normally distributed, and they have a mean of 100 and a standard deviation of 15. And so the first question is a nice standard question. You'll get these more in words as you move forward from 5, 6, and 7, but this is the base. I love to draw pictures when I have those bigger problems, and I would suggest to do the same thing. Hopefully I made that suggestion in the videos. So here we go. We need to find the area of that blue region. Now we've been through 6-1, so we know what we're going to do. We're going to look up a number in the chart, look up the other number in the chart, and subtract the results. So the problem is when I go to the charts, right, and I have my charts pulled up here, my charts are z-scores. I don't have z-scores. I got negative z-scores, I got positive z-scores. What these are IQ scores. And so I don't want IQ scores. I want z-scores. So we have to go find the z-score for 130 by subtracting away the mean. Oh, let me write the formula. Z is equal to x minus the mean divided by the standard deviation is the formula. So 130 is the point that we care about, minus 100 divided by 15. That is 30 divided by 15 for the number 2. Excellent. Let's go get the z-score of the other one. That was 108 minus 100 divided by 15. And what's that equal to? 8 divided by 15. Now as you go do your number 5 and your number 6 and your number 7, most likely you'll have different numbers than me. That's just because they're picking the same problem style but changing the numbers involved. So if I look at 8 divided by 15, I'm coming up with 0.53. Now remember, you're always going to round to 2 decimal places. So I'm going to even express this one in 2 decimal places. So now what we've done is we were in a general setting, a 6.2 setting, and we pushed ourselves back to 6.1. So we're just going to do the same thing that you did in the first homework. We're going to go look these up. Well, let's go look them up together. Remember, we're looking up 2. So let's go find 2. Here's 2.0. Here's 2.00. And that's 0.9772. And let me get in here and erase some things that were part of another description for another student. Or actually, for you guys, it was part of the 6.6. 0.9772. 0.9772. And then we're also going to look up 0.53. So here's the 0.05. Let me get a highlighter. Here's the 0.05. And here's the 0.053. Right? I don't know if that's easy to see. Maybe it would have been better if I circled it. So let me come in here and circle it. I'm in the 0.5 row, and I need to go to the 0.03. And we get 0.7019. We come back here and do our 0.7019. So you know what to do because you've been through 6-1. You're going to subtract those two values, and hopefully it makes sense why. When you find the 0.9772, let me show you what that is. 0.9772, I'm going to highlight it in yellow. 0.9772 is this. This is 0.9772, the full area to the left of the IQ score of 130. So there are 97.72% of all IQ scores below 130, which means there's a small percentage above 130. So if you have a more than 130 IQ, you're in the top like 2%, 2.3%. That's awesome. But that's the 0.9772. The 0.7019, Sorry if that looks like a 2. The 0.7019, let me highlight that in blue. And come in here, whoops, with blue. Here is the 0.7019. Everything below the 108 IQ score. Meaning 70% of all IQ scores are below 108, meaning 30% are above. Okay, so it's the 70th percentile, right? Well, look, if I take the yellow and subtract out the blue, then I get exactly what I want. And so that's why it's happening, just to give you another reinforcement. So the probability that somebody's IQ score is between 108 and 130 is simply 0.9772 minus 0.7019, which is simply 0.9772 minus 0.7019, 0.2753, and you're finished. Right? So I would say, hey, 6 and 7 are the same, but they're not necessarily the same. They're going the other way. They've known you've done both ways before coming into 6.2. And so now, when we're in section 6, so realize that before I move on to the other problem, this was the only thing 6.2 added to you. Hey, you're not a z-score. You're not standard normal. Get yourself a z-score and do everything the same. It's awesome, right? That's why this is such a successful chapter for people, is because you do the same thing over and over. 7 will be similar in the same type of way. What's happening in 7 is just repeated over and over. So let's take a look at what number 6 had. Number 6, my number 6 had an X right here, and then it had a shaded region to the left of X. Yeah, and said it was, see if this, try to make it 0.8. So it was 0.8. That shaded area was 0.8. Well, you know what we need to do. This is the same as the first section. So we are given a probability, an area. So what do we need to do first? We need to go find that probability in here. Probability to the left is here. And what that chart can hand me is a z-value. So I'm not going to be able to get my IQ out of the chart, but the chart can tell me my z-value location. So remember what the 0.8 is. It's an area to the left, right? That's good because that's what this chart represents. Area to the left, inside. So we're going to go inside that chart, and we're going to look in here for the closest value we can find to 0.8. Now remember, we're not usually going to hit it, but then we're going to determine its z-value. Let's go watch this process in action. So I'm going to come here. Let me take a moment to erase all the other marks. And I want you to just look at this chart for a moment and see if you can find the number that's closest to 0.8. Okay, so we're going to scan down. Numbers are getting bigger as we get down, and I'm getting closer. 0.7935, 0.7967, 0.7995. That's super close. That's only 10 thousandths off. So this is 5 off of 8,000. This is 23. So 7995 is our guy. Now we're not going to write down 7995 because we already knew that. What we're going to write down is the z-score that made that possible. And it looks like that's 0.84. Perfect. You can see my little marks and why I wrote them that way. So what we got out of that chart wasn't the end result, right? It was in the first section. In the first section we were done because things were standard normal. What we get is the z-value of this x value, right? Its z-value is, I already forgot because I talked, 0.84. Okay, so z-value is 0.84. Awesome. So now I need to find the IQ score. So there's two things you could be reliant upon, the definition or a formula. You know the definition of a z-score, I hope. It's one that I would want you to memorize. So the z-score is the number of standard deviations a value is away from the mean. We just found out that we're 0.84 standard deviations away from the mean. Well, that's what this formula is doing. X is equal to the mean plus z times the standard deviation. What's the mean? 100, given in the original problem. How many standard deviations is our value that separates 80% of the data below it? We just found out it was 0.84. And what's the given standard deviation from the very beginning? 15. We run that and we'll have our IQ score. That's 0.84 standard deviations above the mean. 100 plus 0.84 times 15, and we get 112.6. Awesome. All finished. 112.6 IQ separates the bottom 80% of the data. Technically 0.7996, but that's 80% of the data, right? It's the best we can do when we're limited with the chart. So what are we going to do for number 7? Same thing. So number 7, though, has an X, and its shaded area is to the right. And what it's telling me, it's using an arrow and the number being on the outside. So this is what it looks like for me. 0.3949 is this blue shaded area. Awesome. Well, we're going to do the same thing. And again, you did this in the first section. We're just going one step farther. So what was the necessary 6.2 piece? That X is equal to the mean plus Z times the standard deviation. So we want to find this value right here. Well, we know what we're going to need to do. We're going to need to access the chart. If we're going to access the chart, well, we don't have a value. We don't have the Z value, but we do have an area. Well, this chart doesn't reflect any area. It's area to the left. So just like in the other section, if you're given the area to the right, you really need to identify this area to the left. This area to the left is 1 minus 0.3949, or 0.6051. 0.6051 is the number that I want to be able to find in the chart so that I could get a location, a Z location for it. I can know how many standard deviations it is above the mean. Let's go find it. So we're coming in here. Again, I'll take a moment to erase. And we're looking for let's remember, 0.6051. So I always model things directly. 0.6051. I'm not seeing it on here. 0.6051. I actually thought we would see it exactly because they picked such an exact number, 0.3949, 6051. We're not seeing a 6051. So which is closer? 6026? These are my choices because I just jumped it. So 51, it's way closer to 6064. So that's going to be our guy. And we're not daunted by the fact that it wasn't there. And so let me just scale this down a little bit so we can see what row we're in. We're in the 0.2 row and the 0.07 column. So 0.27 is our Z value. So our Z value for where we want to be is 0.27. So the IQ is not 0.27. That would be a fairly low IQ. But the IQ that we want is 0.2 standard deviations above the mean. So right now, if this was a standard normal problem, we'd be finished. If the mean was 0 and the standard deviation was 1, we'd be done. But it wasn't. So we need to go find out the IQ score by taking the mean and adding to that the Z that we found times the standard deviation. So X is equal to 100, which was given in the original setup. Z, what we just had to find, standard deviation given originally. We knew 2 over those 3 places before we ever got started, before they ever asked a question. And we get a nice 104.05. Perfect. right? Just show me that work, and that's what we're doing. So what's going to happen later on in the homework if somebody got stuck early is these things in word problems, right? Instead of drawing you pictures and things like that, this one right here is going to say find the IQ score. Sorry, IQ score. That separates the bottom 80% of the data of IQ scores. Maybe that's what they say. I think that's what they would say. That's the same problem. We would draw that picture. We'd want the IQ score that has 80% of the data below it. 80% is a probability. Probabilities are areas, and we would just draw it that way. This one would say, find the if one person is randomly selected, what's the probability that their IQ score is between 108 and 130? And this is what we would do. Draw that picture and do this work. What's 7 going to look like? Find the IQ score that separates the top 39.5% of the data, right? That has 0.3949 above it, and we would do this exact thing. So the problems are very, very similar once you can break through any mental barriers you have as to what's going on. So hopefully this additional video will help.